Artificial intelligence is changing everything. Today, we can ask AI to write code, analyze data,
create maps, process satellite images, and even generate reports within seconds. So the big question is, do we still need to learn coding in the era of AI?
For students, GIS professionals, researchers, environmental scientists, and urban planners, this question is more important than ever. Welcome to Geo-Insight, your hub for geospatial learning. Today, we will explore whether coding is still necessary when AI tools are becoming so powerful. AI has made technical work much faster. In GIS and remote sensing, AI can help us write scripts, classify satellite images, detect land use changes, automate map production, clean data sets, and even explain complex workflows. For example, instead of manually writing a long Python script, you can now ask AI to generate code for raster analysis, shapefile processing, or satellite image visualization. This is a major advantage, especially for beginners who feel coding is difficult. But here is the important point. AI can generate code, but it does not always understand your real-world problem perfectly. Learning coding is still important because coding is not only about typing commands. Coding teaches you how to think logically, how to solve problems step by step, and how to understand what is happening behind the software. In geospatial fields, we work with real-world data. This data can be messy, incomplete, or inaccurate. Coordinates may be wrong, projections may not match, satellite images may contain cloud cover, climate data sets may have missing values. AI can help, but you must know enough coding to check whether the result is correct. Is the map showing the real situation or just a beautiful but wrong output? Without basic coding knowledge, you may trust an incorrect result. And in GIS, remote sensing, disaster management, and environmental science, wrong results can lead to wrong decisions. AI should be seen as a powerful assistant, not a complete replacement for human skill. Think of AI like a calculator. A calculator can solve equations quickly, but you still need mathematics to understand whether the answer makes sense. In the same way, AI can write code quickly, but you still need coding knowledge to understand, modify, test, and improve that code. The future belongs to people who can combine domain knowledge with AI tools. A geographer who understands coding and AI will be more powerful than someone who only knows GIS software buttons. A remote sensing researcher who can use Python, Google Earth Engine, and AI will work faster and produce better research. An urban planner who understands spatial data automation will make smarter planning decisions. Now, does this mean everyone must become a professional software engineer? No. For geospatial and environmental fields, you do not need to master every programming language, but you should learn practical coding skills that support your work. The most useful language to start with is Python. Python is widely used in GIS, remote sensing, climate data analysis, hydrology, disaster risk mapping, and automation. You can start with simple skills like reading files, cleaning data, making charts, working with coordinates, and automating repetitive GIS tasks. After that, you can explore libraries such as GeoPandas, Rasterio, Xarray, Matplotlib, Folium, and Earth Engine Python API. For remote sensing, Google Earth Engine is also very important because it allows you to process large satellite datasets without downloading everything to your computer. The good news is that AI has made learning coding easier than before. Earlier, beginners often got stuck for hours on one error. Now, AI can explain the error, rewrite the code, and guide you step by step. You can ask AI, explain this Python code, fix this GIS script, convert this QGIS workflow into Python, create a Google Earth Engine script for NDVI analysis, help me automate rainfall map generation. This means you do not have to learn coding alone. But remember, do not only copy and paste. Try to understand what each line of code does. Run the code, test it, change it, and compare the outputs. That is how you build real skill. In the era of AI, the best skill combination is not coding alone. The best combination is geospatial knowledge plus coding skills plus AI tools. Geospatial knowledge helps you understand the problem. Coding helps you process and analyze the data. AI helps you work faster and learn more efficiently. Together, these skills can help you solve real-world problems. The way we learn coding has changed. You do not need to memorize everything. You do not need to write perfect code from day one. But you do need to understand the basics, think logically, and know how to verify AI-generated results. AI will not replace people who know how to use it wisely. In fact, people with coding knowledge and AI skills will have a major advantage in GIS, remote sensing, environmental science, urban planning, disaster management, and climate studies. So instead of asking, should I learn coding or use AI? Ask yourself, how can I use AI to learn coding faster and solve bigger geospatial problems? If you are a student, researcher, GIS professional, or anyone interested in geospatial technology, start learning coding step by step. Use AI as your assistant, but build your own understanding. Because in the future, the most valuable professionals will not be those who fear AI, but those who know how to work with it. Thanks for watching Geo-Insight. Subscribe to the channel for more videos on GIS, remote sensing, environmental science, earth sciences, urban planning, climate studies, and geospatial policy insights. See you in the next video.